Thanks for coming out. Glad to see a good crowd. This talk is about clean application development. Do not confuse that with clean code. We're going to talk about the entire application, although I do talk a little bit about code during the talk. My name's Adam Culp. You can follow me on Twitter at Adam Culp. I do tweet quite regularly. And please, after I finish this talk, please go out to Joined In. This is talk 10-439, and rate the talk. I look forward to hearing your feedback on the talk. Those who know me know that I like to talk. I talk a lot. My problem is not talking, it's shutting up. So I do a lot of talking. And I take the feedback that folks give me and tweak my talks every single time to get a little bit better at them. So please, leave me feedback. As Justin had said, I'm the organizer of the South Florida PHP user group in South Florida. From like West Palm Beach down to Miami. We have about 550 members plus in our user group. I'm also the primary organizer of the Sunshine PHP conference. Last year I did the whole thing myself, which was pretty close to suicidal. This year I have a community helping me, or a committee helping me, and we're really looking forward to it. These are going to be given away to each attendee at the conference, so anybody interested in coming and enjoying some 70-plus degree weather in Florida in 3 weeks and get an elephant, please come on out. I'm also a PHP 5.3 certified engineer. I work for Zen Technologies. I'm a consultant. So what I do, my job is, I don't really do much coding for Zen. I do a lot of coding on projects and things like that. I contribute quite a bit to open source, things like that, but I don't do much coding in my day-to-day job. I pretty much go out to companies and tell them their code sucks and here's how to fix it up. So refactoring has become my life, and I love doing that. Just a little bit more about me on a personal note. I am a black belt judo instructor, and I also enjoy running. I run a lot. I'm an ultra marathoner. For those of you who don't know what ultra marathons are, a marathon is 26.2 miles. Ultra means more than. So I run more than 26.2 miles. My favorite races are 100K, which is 62 miles, or 100 miles. Those are my two favorite distances. Now, the reason I bring some of those things up is to tell you a little bit about me, but also to emphasize that I love iteration. Most things I do, from development to running, and I didn't just jump off the couch one day and say, hey, I'm going to go run 100 miles. It takes conditioning. We ultramarathoners, we condition our body to be able to manage that type of mileage. So it's a progressive thing. And martial arts, that's a lifelong study. It's something we get better at over time. So it's iterative. And the same thing with application development. Doing good applications, we get better at them over time through practice. So just know that in this talk, I'm not going to be able to teach you everything in a 45-minute to a 50-minute talk. It's just impossible. What I'm going to hopefully do is help point out some things that you, through practice, can get better at over time. I mean, again, development is something we get better at. There's no silver bullet, so please don't be afraid to share with other people. How many people have done pair programming? Okay, those of you who have not, I'm glad to see so many people have. That's awesome. Pair programming is amazing. If you ever get the opportunity to sit down with a developer, now that doesn't mean both of you are sitting there with your laptops and both of you are coding at the same time. Pair programming is one person programming and another person looking over their shoulder, giving tips, pointing them out, pointing out direction, things like that. You can learn so much through that, either as the person doing the coding or the person helping out. I encourage you to give it a try. Throughout this talk, I'm going to be talking about some things in reference to these two books. Now, there are 4 books that I think every developer should definitely have on their bookshelf. These are 2 of them. One being The Clean Code by Robert Martin, Uncle Bob, he goes by, and the other one being The Refactoring by Martin Fowler. I do want to point out that the refactoring book, I've actually included a URL there for my GitHub repository. This book uses Java in their examples, and they're pretty simple. You can get it, even if you've never looked at Java a day in your life. You can pretty much figure out what the code samples are doing. However, suffering a little bit of OCD, I decide, I want to create a PHP version. So I redid all the code in the book in PHP, and it's at that repository if you wanted to check it out. So please. If you do get the book, and I encourage you to have the book on your bookshelf if you don't, download the code and you can follow along. Now, something else I did in that repository too is It's done as versions, right? So there's actually like 18 files in that repository, and it's like in steps. Step 1, Step 2, Step 3, Step 4. And you can follow along using a diff viewer. You can look at version 1 through version 2 and see how the refactor was done, what lines were affected. So enjoy that. Now, in this talk, again, we're covering clean application development. It's going to cover a lot of aspects of the whole application, not just the code. But I'm going to talk a little bit about the development practices. So what causes bad code in the first place is of course something to really focus on. As we're writing bad code, there's many things that influence how we write our code. First off, writing bad code is easy. It's a lot easier to write bad code than it is good code, especially as you're learning to develop. I've written a lot of bad code over my lifetime in the 14 plus years I've been a developer. And the thing is it was just easy to do that. Now, as I've gotten better at development, I'm now finding that it's actually easier to write better code as you get used to it, but it's a learning process. Short deadlines, or maybe an impatient boss. Other reasons that influence us to take shortcuts and do things that we might not normally do. Laziness, developers are notorious for being lazy, and I'm right there with most of them, when it comes to doing things and taking shortcuts. Lack of how-to. As we're learning development, we don't know how to do it better. But in PHP part of its blessing and its curse is being easy to use, right? Well, by not knowing it, it's just easy to hack something together. And it might really suck, but it still works and it gets by. So the lack of how-to helps us with that. Coupled applications. Does everybody understand coupled applications? Who doesn't understand coupled applications? Be honest. Okay, that's good. That's good. Good to see some hands. So as we develop our applications, we might create files that extend other files, or classes that extend other classes, or maybe one part of our application depends on another part of the application. Paul Jones did a talk here on decoupling your applications, and the thing is the more decoupled your application is, the less it trips over itself, because then you're not relying on one part to use some other part. So I would encourage you to look a little bit more into that. Loosely coupling your application or decoupling it entirely really helps with the flexibility of your application and how you can use it. Other reasons that we might turn to some bad practices are bored of the same old thing. We're all doing, many of us are working on the same application day after day after day, and it's really easy just to get bored of it and say, I just want to get this out of my hair. I see a ticket over here for something exciting, or there's an exciting project coming up. I want to work on it, so I need to hurry up and get done what I'm currently working on. Well, as we look down through the list here, there's all of these things pretty much point to us. We're usually the underlying cause of why these bad things happen. Now, us as developers, one thing that we have to face up to is that it is our job to defend the code. We as developers need to learn to say no. We need to say no to ourselves. We need to say no to our bosses. We need to say no to anybody that's influencing, any outside influences, even ourselves, for writing bad code. Keep in mind, though, that our managers, their job is to defend their scheduling and their timelines and their features, right? They're selling features to businesses to make the company sell, to make money. And they're defending their schedules because that has to be done in a certain time frame to enable them to be able to make that kind of money. So we as developers have to be conscious of that and realize that it's their job to defend those things. Excuse me, but our job is to continue to defend the code. And we really need to do that. Now, I'm not saying become the guy that always says no. Don't just say no and expect everybody to bend backwards and say, okay, no problem. We won't do it. You have to be able to defend it and quantify it. Why am I defending it? Why am I not going to do this? Have some of those things ready. And be prepared to lose some of those battles too. Defending the code, it's our job, but it's not like we're going to win every single battle. Sometimes you have to give in. Okay, I'll do that this time because I realize the importance of it. We need to make money as a company. But just know that later on I'm going to come back and I'm going to win the next one, right? So we have to work with it that way. As many times we cause it through other methods, such as when we start with a new company. Bad code starts very innocently. To kind of give you a story, a new developer gets hired with the company. And the new developer, of course, he's gung-ho, he's very excited, he has a brand new job, he or she has a brand new job, and they're excited to be working on this. So they're sitting down and they're talking with the boss, and the boss, especially if you're with a startup, they're very emotional about what's going on. And that excitement breeds and extends out. So what you end up with is a startup manager describing the application. Well, the developer, being excited about the new job, and of course wants to prove that he's able to do what he was just hired to do, rushes off to his desk and really fast knocks out an application, takes it back to the boss, and the boss is like, wow, that was fast. How'd you get that done so fast? How many people have done that? You did something really quick and took it back to the boss? Wow, that was quick. Did you do unit testing? Did you do any planning? Did you do any design at all before you actually went and did that? Chances are not. And we've all done it. I'm not pointing to anybody and saying it was wrong or bad. It's just the way it happens. But, well, it is wrong, but maybe not as bad because you did it in context, right? But the thing is then the boss tells you in the very next breath, well, what if we tweaked it and added this? Or what if we did that? So then excited, you go back to your desk, and once again, you knock it out really quick. You take it to your boss, and he's like ecstatic at this point. But in the back of his mind, what happens? This business manager is now starting to develop a new perception. Well, wait a minute, I thought development was harder than that. And now this developer all of a sudden is whipping this stuff out really fast. So the perception is being created in the manager's mind that now things can be done faster. So he starts to push a little bit, and he starts giving you more things to do. And the application starts growing and growing and getting bigger. We're not following best practices. Now we're being pushed to do things faster. So things just kind of steamroll like a domino effect, getting worse and worse until finally the day comes that you hurry up and you get something out, you take it to the boss and you show it to him, and sure as hell, a bug pops up. And the manager, that's ugly. You just showed me something that's buggy. So now the developer will become defensive. Next time he'll go back and he'll pad his estimate a little bit. Well, I don't want that to happen again. I don't want my boss to see that I made a mistake. So he starts padding the estimates, and the timelines start to grow. The application becomes even more complex and more entwined, usually very coupled. And then you're taking it to your boss, and this continues for a little bit longer. After a while, the boss starts giving you requirements, and the answer is, how long will it take? Or the question is, how long it'll take, and your answer is 6 months. And then he comes up with another new feature, and the answer is 6 months. So before you know it, everything's taking 6 months, right? You're estimating, and because you want to make sure that you have plenty of time to test it, plenty of time not to be confronted with some of these bugs. And then one day, the inevitable happens. Your boss says, hey, we need to add this. And you're like, I can't continue to do this. We really need to rewrite the application. Because you've gotten yourself to a point where now the application is unwieldy. It's almost impossible to include anything else. So what you end up with then is coming to terms with, do I rewrite or do I refactor? We obviously have to do something major because we got some big problems here. So when it comes to that, of course, the business has just paid you for X amount of months, your salary, to build this. And in their mind, the first thing they're thinking about is, oh, wait a minute, I just paid an $80,000 salary for this year for you to build this, and now I got to pay that $80,000 salary for another year to rebuild it. You're not going to give me anything new. It's going to be the same application, but I got to pay double. From a business standpoint, we can all see that, right? It's not a good boat to be in. We don't really want to be there. Not only that, you also risk losing, this kind of goes back to refactoring talk that I had yesterday. We risk losing business logic, whenever we do a rewrite versus a refactor. There's lots of reasons why a rewrite can be kind of hazardous. So as long as you know the pitfalls of it, you can kind of avoid it. So, and two, when it comes down to rewriting, let's say you do finally convince the business, yeah, let's go ahead and rewrite. Generally what they'll do is they'll look at the team of developers and they'll say, okay, well, we have the experienced guys who have been here the longest. They understand the business model. They're obviously the logical choice to build the new application. They're more experienced developers in many cases. So what they do is they take those experienced guys and they put them on the new application building project. And the newer guys, the less experienced developers, they get to maintain the old one. Well, before long, as is the case with most business, customers request new features. They need something added. So the business turns to the developers who are maintaining the old application and asks them, can you please put this in? And they say, sure, we can put it in. And they do. They put it in. Well, what's happened to the new application? It now has experienced scope creep. Because not only, there's no way you can have a brand new application and not include this new feature, right? So now your new application is experiencing scope creep, and the developers try to jump through hoops to try to get that done. Before you know it, 6 months, a year goes down the line, and the business comes back and says, where's my new application? You've been working on it, you guys, and what's going on? And of course, the developers, they point fingers. Well, you changed things. You added new features. It's you caused the scope to creep on us. So business continues to push, and the developers feel the pressures from the original application. And how did they handle that? They fall back into their old practices. The things that they did on the old application to make it bad, now they do it in the new application because they're in a hurry, they're in a rush. Business is pushing on them. So it's a vicious cycle that they end up in. And of course, after they get that all done, then they're faced with 2 bad applications now instead of just one. What do? Do we rewrite it? So with all these problems, it's easy to see why taking care of doing things the right way from the beginning or changing the way that you work to do things better right from the beginning is the better way. It just makes sense to follow clean application development and taking care of things. You have less bugs, you have happier end users, your business is happier because you'll have shorter timelines for development because things are more orderly. We as developers spend a lot more of our time reading code than we do writing code. We very rarely sit down in front of our computer and just start writing code. We first have to read the code to see, okay, where am I going to add this feature, this functionality? How am I going to put this into my application? People following behind us, they don't know the application. They certainly can't just start coding. They have to get to know the application first. So they start reading. If the code is not written well, if you're not following conventions, if you don't have any sort of coding standard in place to give somebody a guideline of how the code is arranged and how things are done, then it makes that reading take a lot longer. Therefore, our development cycle is also much longer. Whereas if we can shorten our development cycle by doing things the right way. And then after things have gotten to the point where it's bad, we end up looking at our code. Now, if you look like this guy when you look at somebody's code, somebody's messed up somewhere, right? So what we do is the result of that is you have wasted time because now you have to spend much more time reading the code versus writing it. You have more bugs because everything's intertwined and tripping over itself. You have excessive debugging because now you're constantly having to debug just to develop. How many people are good at debugging? I see a few hands. How do you get good at something? We get good at debugging by having to debug a lot. So if we write better code from the beginning, we do less debugging. I find that the people, you know where I'm going with that. Anyway, so also causes procrastination. If something is bad and you have to be faced, with, working with it, we procrastinate. We stay away from it. We work on something else. We find something else to do. It causes missed deadlines. Technical debt. Everybody understand what technical debt is? Technical debt, I see some people with a little bit of confusion on your face. So technical debt, think of it as kind of like credit card debt, right? So we get a brand new credit card, and of course we go shopping. We buy things on that credit card, and before you know, the limit on that card, or the amount that's charged on that card goes up and up and up. Well, once you get it charged all the way up, you have one of 2 solutions. Either you pay it off a little bit at a time, make your payments, whatever the case might be. Hopefully you're responsible with credit, so I'm not going to get into that. This isn't a financial talk. But on the other hand, though, if you decide not to pay it off, your other alternative is to go bankrupt, much like rewriting code, right? So technical debt is much the same way. Once your bad practices in your code get to the point where your code is bad, you either need to refactor it in bits and pieces and improve it, or you go bankrupt and you rewrite. Again, we covered some of the bad things of that. Technical debt and writing your bad or having bad code also can result in financial loss. You have a company, a customer faces the company and says, I need this new feature. Otherwise, I'm going to leave you and go to this company over here because they already have this feature that I need. So the company is faced with having to do it. Well, if the code is bad and the developers take too long building new features because the code is bad, they have to spend so much time reading the code, it can cause financial loss for that company. Companies actually go broke because of this, because they can't build new features and they start losing customers and start bleeding, business-wise. And then as developers, another result, developers, I didn't write it, he wrote it, she wrote it, whatever. Of course, your version control, if you're using version control, and you should be, you can always find out who actually wrote it, but it's easy to point the finger to someone else. So after we've gotten to that point, then the aftermath, of course, is severely padded estimates, like the developer who everything takes 6 months, you need to add some small feature, some small thing, 6 months. Developers tend to hide. Especially freelance developers, it's a little easier, right? Because we just don't answer the phone. But if you're working in a company, you can't hide quite so much. We become defensive, we blame others, change jobs, whatever the case might be. One thing to be aware of, though, is if you have been writing this code, and now other developers who follow behind us, they have to read the code. We're authors. They're reading our works. So they know what we did wrong. They know how bad we did it before. And developers do talk about it. When you're in circles, developers, they know who wrote the bad code. They might not mention you by name because everybody knows you did it. So just be aware of that. People are reading your code. Be responsible with your code. Defend the code. One of the ways to do that is by using coding standards. Using different coding standards. Now, today, one of the popular coding standards out there is PSR. Everybody heard of PSR? The PHP Framework Interoperability Group, yep, at php-fig.org. I encourage everybody to take a look at the standards out there. There's PSR 0 covering auto-loading using namespacing. There's PSR 1 for basic coding standards. PSR 2 covers coding style guide. And then there's logging with PSR 3, and then there's the new PSR 4, which was just recently done, covers improved auto-loading. Now, one thing that I do want to emphasize here, a lot of people get defensive when you talk about coding standards and styles and things like that, and how dare you tell me how to do my code? Keep in mind that it's up to you to come up with your coding standard. This is a guideline. This is not so much a standard of here's how you have to do it, but it's somebody, a group of people, a group of these different framework, building the frameworks and the applications today. They've pretty much voted on it and said, this is how we'll try to format our stuff and follow. It's a I'm forgetting the word. Anyways, it's not a requirement, it's just a possible starting point. So look at these, read them, get to know them a little bit, and if you don't like them, that's perfectly fine. Don't use the parts you don't like. But still, above all, choose a coding standard. Have a coding standard and use it daily. Make sure everybody on your team is using it. If only one person on your team is using a coding standard and the other guys aren't following the same coding standard, then you're not going to get anywhere. There's no benefit to it. I often say one thing to a lot of development teams. I work with teams quite often. Consulting with Zend, I'm often traveling and working with many development teams. And as I'm working with those teams, I always encourage them, come up with a coding standard, let your whole team vote on the coding standard. Get everybody together. And the question I always get is, well, what if we don't agree? Well, if you don't agree, then your architect is a decision maker. That's the person, it's their application. Everybody else is working on the application too, but your architect, he's your lead. He or she is your lead. When it comes down to it, that is the tie-breaking vote. And if you don't like it, leave. Go work on another team where you can make the choices, or where that architect might agree with your decision. But above all, let everybody vote on it, but when it comes right down to it, somebody has to make a decision, and everybody has to go forward. If you're not going to cooperate, then it's time to find a different team. So some other things to consider when it comes to code is naming, right? So we want to make our code as self-documenting as we can. So we come up with good names, instead of using something like elapsed, which really doesn't tell us a whole lot, maybe elapsed time in days, or something along that line. I'm not going to go through each of these, but just, make sure your naming is nice and clear and understandable. And when you're using names to identify something, try to be consistent. If you're faced with code where you see something like product, product info, product data, and product description, what's the difference between those? But yet if all of these are used throughout the code, how do you know which one's which? So pick something. I mean, if you're gonna make an array of all your products and it's going to be all the data related to that, give it a certain name and stick with that throughout the application. Try to stay away from characters that are hard to read inside the code. When you're using a lowercase L or an uppercase O, which can be confused with a 0, or an uppercase I, it's hard to know whether that's an L or an I sometimes, depending on the font you're looking at. Try to shy away from things like that can cause some issues. Grammar within your application. As we're creating our class names, a class name should be more like a noun. It describes something like customer or account or product or companies. Our method names or the functions would become the verbs of get customer, close account, and it's just a little bit more, creates more clarity inside your code. Pick keywords and stick with it. So if you're going to use fetch, don't use fetch in one place and get in another place. Keep fetch your standard throughout your code base. And these things should be documented within your team and within your project, so that way somebody coming in and reading the code afterwards knows exactly what they're looking at and what they're reading at. What's the difference between remove and delete? It could be argued that one's one thing and one's another, but document that. So a little bit more on clean code functions. Your functions should be kept nice and short. It should be said that functions should take care of one thing. If your function is only doing one thing, it really doesn't need to be very long. You're only doing one thing in your function. If you find your function, my rule of thumb for myself is if my function is longer than 20 lines, I did something wrong. That's me personally. You might have your own benchmark. That's my benchmark. I try to go for as little as possible. Recently, I used in some code that I've been doing, there's a tool out there called PHP LOC. You can find that at phpqatools.org. There's a lot of tools out there at phpqatools.org. PHP LOC is for lines of code. Generally, my functions fall in the 10 line or under range, but 20 is my max. If I reach 20, I know I need to break up that function. It doesn't really take that many lines to do one thing. And functions should also be single purpose, to go along with that. And when you look at a function, it should be named appropriately. And as you're looking at 5, 10, or in the extreme case, 20 lines of code, you should be able to tell pretty quickly what it's doing. You look at the name of it, and then you look at the few lines of code below, and you kind of look at it and say, well, yeah, that's exactly what it's doing. You don't have to hunt through your code. It makes your code much more readable. And again, we spend more time reading, so it allows us to develop faster. And they should be well named. Coding should make the language look simple. I've seen a lot of PHP applications out there that are just, you look at it and you're like, oh my God, this is such a hard application. It's so hard to read. It's so, surely it's doing a lot of complex things. And in many cases, they're not. It's just that the code was not written in such a way that it's clean. And by doing that, then the application to read it just doesn't look very, very easy. We as developers, especially entry-level developers, we can look at code and tell that it's bad, but we don't necessarily know how to make it good. Much like a song, right? If you hear a song on the radio, you can tell if it's bad. Wow, that song sucks. It doesn't mean you're a songwriter. So the same thing with code. We can look at code and we can look at the application and say, wow, that's kind of bad. It's hard to read. It kind of sucks. But it doesn't mean that we know how to do it. So practice makes perfect. Keep going about it. And also, clean code usually doesn't require many comments, if any. Now, I'm not saying don't comment your code. Please don't crucify me with that. I do want you to comment your code. Please comment your code. However, if your comments inside your code are simply covering up bad code, you're doing it wrong. You need to rewrite the code so the code is nice and clean and simple, easy to follow, and then your comment should be something brief. As an example, we could look at something like this, right? Here's two examples. The top one, we're doing an if comparison, and we're looking for an hourly flag. We're also looking at the age greater than 65. And so we have to pretty much, in this case, have a comment saying, here's why we're doing this. Consider the alternative. If we break that condition out into a function on its own, and then we make that function is eligible for full-time benefits, we just made our code self-documenting. Do we really need a comment to explain that? That's what I mean by be careful with the comments in your code. Now we would have to put a comment on our function that we just broke out using extract function, but at the same time, in our code here, we really don't need to comment that, so to speak. One of the things that we need to be consistently looking for is smells in our code. Smells, everybody understand smells? Who has not heard of smells inside the code? Good, we got a few. I say good, not because you should know what smells are, but it allows me to talk about it because now people need it. So anyway, smells are indications of problems in your code. A smell, just like something being spoiled, the smell itself is not the spoil. It indicates that there's something nearby that maybe we need to look at. There are many code smells. If you want to see the different code smells, I'd encourage you to download the slides that from my refactoring talk I gave yesterday. I actually cover all the smells in that talk. I'm not going to cover them here. However, smells are indicators. They're not the bad code itself. And comments are one of those. Like I just talked about comments. Comments can be a code smell if they're covering up bad code, but comments themselves are not bad. So that's a good example. So smells, some possible smells that can cause us to have our attention drawn is incomplete error handling. How many of you have inherited a legacy application? You turn on error reporting and you bring up the page and all of a sudden you've got a whole page, if not more, multiple pages of errors and notices and everything else. It's scary sometimes. That indicates that there's a problem there. That developer was lazy, didn't take care of initializing variables and things like that. So obviously there's going to be other issues there. It's pretty much a given. However, that's just a smell. The fact that all those things are there isn't necessarily a problem. It's just that the developer was lazy and didn't feel like following good coding practices. Memory leaks, race conditions, where one part of an application might not have been done soon enough to allow another part of an application to function properly. Inconsistent naming between classes, functions, and variables. Inconsistent coding standards. Uninitialized variables, again, we talked about that just a moment ago. The code lacks clear purpose. If you're looking at a function and it's named something, and then all of a sudden you've got 1,000 lines of code within that function, how can you possibly look at it and see if it has a clear purpose? Excuse me. A function doing too many things. Again, going back to the functions, they should be nice and simple. They should really only do one thing. If a function is doing too many things, you break that out, put it into another function, and call it. Makes your code a lot more self-documenting, easier to read. Don't use globals. Globals being used is a bad thing. When using globals, I sigh because I recently looked at a code base for somebody, and they use globals everywhere. And as I was going through, I was trying to figure out where did that variable get set? How do I figure out where that variable was initialized? And then I finally found where the variable was set, but that wasn't the value that I was getting. So it obviously got changed somewhere. It's almost impossible to figure out where these globals are actually being changed and updated. That's why we stay away from globals, because it just makes it too hard to read, too hard to follow the code and figure it out. You really have to do a lot of debugging, with some sort of debugger like Xdebug or Zen Server's debugger to really figure out, what's happening with my globals. How can I figure that out? Too many comments in the code. Sometimes I've seen code where there's just books and books of comments inside the code. Well, if the code's that complex, obviously there's an issue there. And then warnings and fatal errors. There's a tool out there called Code Sniffer that works really well to help us write better code. Anybody using Code Sniffer? We have a few people. Good. There's even inside today's modern IDEs, Zen Studio, PHP Storm, you can actually link Code Sniffer to it. So it can actually check out your code for you in real time, and you can see if you're following practices. So basically, you tell Code Sniffer, here's how I want my standards. For those of you using PSR, there are already sniffs created for PSR. So you can just plug it right in and let it do its job, and it'll tell you if you're PSR compliant or not. And you can use that to really help you, and stay compliant. Also, peer reviews are another way to keep track of our code. Peer reviews. I worked as freelance prior to working with Zend. I was freelance for about 13 years, 13 years. I often had other developers say, hey, can you take a look at my code? Basically look over my shoulder. Tell me if I could have done something better. I've done that personally, approached other developers and say, hey, can you take a look at this? And tell me how bad it sucks. And I really want to know that. So the peer review is for that. A peer review is a chance for a developer to get feedback, real lifetime feedback from other developers of what's going on. One way to help us code is using design patterns. Everybody using design patterns or understand them a little bit? Yeah? Design patterns are pretty awesome. Now, the trick with design patterns is you're not going to just one day learn all the design patterns and know how to do it, right? A design pattern is not a static thing. A design pattern is just a certain pattern that your code could follow to solve common problems. So we as developers these days, we really aren't doing anything quite so unique and quite so new. Many developers have followed before us, and they've already documented ways that they solved those problems. There are many books out there to do that. Jason Sweat wrote a book for PHP Architect for PHP design patterns. It's a little bit dated, needs to be updated. It still has some PHP 4 stuff in there, but it's still good practice. And then, of course, there's the Gang of Four design pattern book, which I think everybody's had. This is another one of the books that I think every developer should have on their bookshelf. Now, I will forewarn you, those of you who have not read it, it is damn boring. You will sleep reading this book. I took many naps reading that book. However, it's a very good book. The bits and pieces in between naps was very enlightening. There's and now there's another new book out too, which I'm actually reviewing right now. Brandon Savage wrote a brand new design pattern book, and it's centered around PHP. I'd encourage you to check it out. Again, I'm reading it now. He sent it to me 2 weeks ago and asked if I'd take a look at it. I haven't quite got through it yet, but it's promising what I've read of it so far. Brandon is pretty good when it comes to design and stuff, and he's got some really good ideas and how things work. So his book seems to be along good lines, and I'll include that on this slide once I finish reading it. I don't want to include it prior to reading it fully. Some other ways to help us do clean application development is by using frameworks. Frameworks that have already designed some of this stuff for us, and they've done the heavy lifting. I'm not really going to advocate any certain framework. There are many frameworks out there, many different methodologies used in these frameworks. But as developers on projects, we should be using frameworks. Please use a framework. One word of caution is don't create your own framework for your companies. Please don't do that. There are many developers who are going to follow you, and you're not really being responsible to the company you're working for by doing that. Companies, their idea is to stay profitable. A company cannot hire developers effectively if the framework is custom. So it makes it hard for the company to hire new developers. Please don't do that. Don't put your employers in that situation. Use a common modern framework. There's a lot of good ones out there. And again, this is not a one-size-fits-all talk. Your mileage may vary, but generally speaking, please stick to a modern framework so that way the company can find developers easier and developers can kind of know what to expect out of an application because they know a certain framework and the way it works and things like that. The more modern frameworks, most of them are using MVC, Model View Controller Design Pattern. Now, if you're going to use a framework, and I encourage you to, you should stick to it. Don't stray from the framework. Now, I realize no framework solves every single problem, right? And not every framework solves every single problem really well. There may be weaknesses in the framework. There may be some problems there, but please stick with it as much as you can. And then later down the line, when that framework comes out with a new version, maybe you've even contributed to that framework to make that functionality better. Hopefully you do. Please contribute. But as the framework gets better, maybe they'll fix that thing. And now you won't have quite as much refactoring because you stuck with the framework. So again, we're talking about enterprise level type development. Try to stick with it. Another thing to be aware of is as we're looking at applications, they're architected, right? So we have a certain architecture behind that. Architecture in the terms of buildings, we're looking at things. We look at a picture like this with rows and rows of books. We see some reading rooms and some other things. We can look at this from a top-down view and pretty much tell this is a library, right? It's pretty standard, pretty easy to look at. We can look at something like this where we see cars driving through, obviously what looks like a barn, and we can kind of surmise what this structure is used for. Architecture can be very clear in telling us from a top-down view what we're looking at. However, looking at some of these modern MVC frameworks, can you tell what they do? The architecture is not quite so clear, is it? When we're looking at this, can you tell what this application does from a top-down view? The architecture is very hidden. I would encourage all of you, especially, many people are smarter than me at this. I'm not a framework developer at all. We really need to come up with a way of making this more clear. And I'm not saying that we should break it up, but if I were to look at something where the architecture is a little bit more clear, it's easier to tell what the application's doing, right? We're able to see, products and things. We can kind of surmise that maybe this is a shopping cart. We should strive to make our architecture much more clear in our frameworks than they are today. Unfortunately, I see many frameworks going the opposite direction. They're becoming much more complex, and they're actually hiding the architecture a lot more for us. And I think that's a shame. But at the same time, there's a lot to that. It's not a simple subject. But please, those of you smarter than me, please work towards creating frameworks that are simpler to look at architectural-wise. And as we're developing applications, please test your applications. How many people are using unit testing? Wow, that's nice. I'm glad to see so many hands. That's good. I can't tell you, I just got a chill. That was awesome. Please, if you're not doing unit testing, please do unit testing. Now, that's not to say every single application is unit testable today. Okay, I realize that there's a lot of legacy applications out there that it's next to impossible to write unit tests for. You should strive to get your application to the point where you can unit test it. Unit testing is actually quite simple. You're going to build a function. Now, keep in mind that each test in a unit test should test one thing. Please don't have tests that test multiple things. Each test should test one thing. If you need to do two tests on one function, write two functions to test that one. That way it's nice and clean, encapsulated. So as an example here, we can test is owned by. We're calling the application is owned by. We're passing in the ID and the user ID. And then we're asserting is it true. And our test passes or fails, whichever accordingly. It's quite that simple. Unit testing really doesn't need to be too complex. It's very simple. Now to do this, you can see I'm using this ID and this user. So chances are those have been injected into the class that this function is a part of. So that way it makes it a lot easier for us to mock things out and a lot easier to test. Well, testing is very important. It's something that we all should be doing, and those who aren't should be doing it. So if testing is so important things should be done first, right? And that leads us to TDD. If testing is so important, we should be doing it first. A lot of people feel daunted by that. I did. I was like, how can I possibly test my application first? Well, I came from a situation where I was working with a lot of startups. I was freelance, and I was working with a lot of smarter companies. I wasn't getting the most requirements in the world. The company would say, I want this. I don't care how it works, just do it. Just make it, and then we'll tweak it later as we go, right? I don't mind paying you by an hour to do that. And they're going to pay me a lot more per hour to do that because I'm going to spend a lot more time tweaking later on down the line because they didn't give me requirements. But companies just don't see that. They see that they need an application, they need it fast. So if you have requirements, we should all be requiring requirements. We should all require requirements from our companies and our jobs. If we do that, there's no reason why we can't write tests ahead of time. We know the end result. We've got the requirements. So please get requirements. That's part of clean application development. And then you can come back. For instance, here, if I'm getting a list of applications, this is actually a snippet taken from a site that I did. It's my own personal site called Rec Harbor, REQ Harbor. .com. I built it for my customers to give me requirements. So, and what they do is they define an application. So here I'm getting a list of applications that customer's created requirements for. And so I'm calling a function called getRequirements, or getApplications rather, and it's going to give me a list of the applications. And then if the resulting array is not empty, then the test is going to be returned, true. Well, now that I've got that test, all I have to do is go into that class and create a function, getApplications. It's just that simple. Now my code has become much more simplified, writing my tests first, because all I have to do is write enough code to make that test pass. My functions now are much smaller. You don't need much to make a test pass, a single test. So it allows us to get much smaller, much easier. Well, getting requirements in that manner also enable, if you're working with a tester, I work with a QA engineer many times, and as we're working with testers, if we get those requirements ahead of time, then it enables us to, instead of having the QA tester at the end of the cycle, now we can move them to the beginning, right? So now they don't have quite so bad of a job. Our QA engineers, now we can move them to the beginning. Let them write some tests. I have a QA engineer that writes all my unit tests for me. They write all my unit tests. All I have to do as a programmer then is write code to make their test pass. The test pass, I'm done programming. Now, that QA engineer after that, what do they have left to do? Just a minor functional test. Because logically, the application's sound. I just satisfied their tests. Other ways to follow clean application development is Agile. Where am I time-wise? Justin's not in here to give me my warning. Okay, I'm good then. Awesome. I was wondering because I saw people filtering in. So we're good. So another way to promote clean application development is Agile. Everybody using Agile? Anybody not using Agile? Be brave. Okay. What's that? Yeah. Okay, stay up there. Paul Jones, everyone. I won't tell you what the M stands for. So Agile, generally what I find that most development shops are using a 2-week cycle in Agile. So they're doing 2 weeks worth of development. And now one thing to keep in mind is if you are using Agile, that means that you get everything done within your sprint, right? Everything. That doesn't mean that you give everything to the QA tester on the last day. It means that you give everything to the QA tester in enough time that they can test it. So everything is done on that last day. And you should also be using your velocity charts. Make sure you post them out on the wall for everybody to see. So that way your business people who are relying on this functionality you're building, then they know how screwed they really are when you're falling short on time. The purpose for Agile, I usually get some comments with this, but please don't comment. We'll talk about it later. The reason for Agile is not so much for developers, in my opinion. Agile is built to help business. It's a way for business to understand the development cycles. So that way when the development cycle falls short, then the business people know that they need to recover. They know that they need to reach out to the customer and say, hey, I'm sorry, but this feature's fallen a little bit short. We're going to be another couple days on it or another week or whatever the case might be. Agile is meant to help business understand the development cycle. Now, of course, it does help developers in a roundabout way because it gives us more structure to our projects and things. But ultimately, Agile, in my opinion, is more to help business, understand that process. So if we're following all these best practices and we're doing all these great things, we're being professionals. We're living up to our title. Please be professional developers. If you go out and hire a doctor or a carpenter or whatever professional you hire to do a job, you're expecting them to do a job to a certain amount of standard. If you go from one doctor to another, generally you're going to get about the same answer. If you go from one carpenter and all of a sudden that carpenter, let's say he dies and he's halfway through building your house, chances are you're going to be able to hire another carpenter and that carpenter is going to be able to pick up where that guy left off. Because professionals have a set standard. They have a set way of doing things so they can follow behind each other. We as developers should strive to be there as well. We should be totally replaceable. If we happen to fall off of a project, they need to get another developer, that new developer should be able to pick up and run with no issues. So please strive to be professional developers. Live up to that title. You're certainly being paid the salary for it. So live up to the title as being professionals. So in conclusion, we've covered a few different things. We've talked about learning, constantly practicing, constantly getting better, creating clear architecture, following coding standards, using frameworks if you're working on big projects, doing testing, implementing Agile, learning to say no and defending the code. That's part of our job. And being professional. I encourage all of you, please be professional. My name, again, is Adam Culp. You can follow me on Twitter. Please rate this talk on Joined In so I know what you thought about it. You can also check out some of my blogs on geekyboy.com. That's my personal blog. And also some other references here. These slides have already been added to Joined In, so please feel free to go out and take a look at them if you need the link to the refactoring code and everything else. Thank you for coming.